All right, welcome to Lab 10, Mid-Latitude Cyclones, and we're going to be talking about a type of storm that occurs at the polar front, which is the low pressure that separates the top of the ferrule cell from the base of the polar cell. So we just finished talking about air cells in class, and this lab is going to tie into that lecture. And take a moment to read the first page, 107, that talks about polar front theory. And then starting with the page 108, you're going to actually work with questions about polar front theory. And so you're given this little image of 4 different weather stations. And each weather station should line up with one of these events, and you have to kind of play the guessing game where you're going to attempt to match the right letter weather station to each event. So the Monday events are on this line, Tuesday and Wednesday. And they are divided up so that this here is the same station letter as this one, that is the same letter as this one. So they have to all be the same one. So if I said this first one was A, then A has to match in this section, and this section for A. So first step is question 1 says label the air masses on each of the 3 maps. So once again, air masses were those setups where it started with a lowercase m for maritime or a lowercase c for continental, and they are the air mass that would be behind the front drawing. So our cold front, which is drawn right here with the little icicles on the front side, would have to come from somewhere on the continent. And so this isn't the labeling part, I'm just showing you. And then this is our warm front over here. So I'm just kind of drawing in who's what so that we remember that, the cold front and the warm front. As far as air masses, I can see that this first cold front is coming off the continent because it's behind here, right? And so it's coming off the continent, so it's a lowercase c. So I'm labeling the air mass C. And then the next part has to do with the latitude. It could either be equatorial, tropical, polar, or Arctic. And this is going to be polar because it's happening in the westerly ferrule cell region. So it's going to be a capital P. So lowercase c, capital P. Same thing for this mass, C, P. Same thing over here, C, P. On the other hand, down here off the Gulf of Mexico is where this warm front's coming off. And since it's coming off the water, it's a lowercase m. And this is in the tropical regions, so I'm going to give it a capital T. Same thing here, M, T. Same thing here, M, T. So that's my first question, question 1, where I'm just labeling my air maps. Then question 2, on all 3 maps and at each station, A through D, use the standard wind symbols to depict wind direction. And then question 3 asks for the condition of each station done in the model. So question 2 and 3 are asking us to identify which station is which. And so we're going to look at these points and we're going to play like a game. So if I'm going to start with this point right here, and I can see that the wind direction is coming in from a funky angle, right? It's coming in from the below or to the south-ish. So I've got a southeasterly wind. I can also see that it's completely dark. So it's very, very covered. So it has to be somewhere where the storm event is taking place. And that kind of leaves me with 2 locations that have possibility, and that would be star D or star C. And so I'm going to go down to my next Tuesday map and see if it fits for D or C on the Tuesday map. And so Tuesday, I can see the wind direction is coming in still from a southerly kind of exposure, and that it's bad weather because I've got a little rain symbol with the dot, and it's still partially cloudy. D is kind of far behind the storm at this point now, and the wind is definitely going to be coming from the west because it'll be behind the front. So I'm liking C now for my potential. I'm kind of weeding out. And then finally, I just want to make sure that it matches C on the last one. And the last one does. So this last one does. So I'm going to label this first one as station C. So now I'm going to do the next one. I'm going to look at this station here that has a tail coming in from a westerly. So this wants to be on the interior, somewhere where you have normal wind conditions. And so B, kind of, mostly A. So I'm liking kind of B or A as potential. So then I want to take a look at the next one, and A is still getting its standard westerly winds. And then I'm going to look at my last one, my Wednesday, and A is kind of behind the storm and still getting its westerly winds. So I like A for my Monday. So that just leaves me B and D left. And I'll leave you guys to do these last two. All right, so now questions 4 through 10 are looking at actual mid-latitude cyclone maps. And so I'm going to flick to the next page where they're located. And you're going to be looking at this mid-latitude cyclone storm and how it's progressed over time. And you can see that we start out on November 9th at midnight, which is written down here. And it's starting to develop out here, right? And it kind of converges in on itself here, and then we get the full storm in this event, and then this is the storm coming to fruition, breaking free and sliding across the map. So I've got different events in time, and each question has to do with these events, and basically everything that you did in exercise 9, where you were labeling pressures and variation of wind direction and fronts. You're now taking that information that you were labeling and you're reading it and doing answers for these questions. So question 4 just reads, how much did the pressure drop in the storm center from November 9th at the 12Z until November 11th at the 000 in there. And so for this one, I'm just looking at the lowest pressure compared to the highest of the low pressures. And so on my map, for my first one, I can see that my pressure was 1,000 at my low pressure center, right? And we're going to see how much it dropped. And let's take a look at this map. This bottom one is a 976, and this one is 970. So 970 is the lowest pressure out of my 3 maps, which means that if I go to question 4, I go to fill it in, how did the pressure drop in the storm center? Well, it dropped from 1,000 millibars to, I forget what I said, was it 970 millibars? And once again, I'm writing with like a big stylus, so you write nice and clean. But that would be my pressure drop from those dates. So I'm being literal on these questions. Question 5, how did the surface pressure gradient over the upper Midwest change during the 36-hour period? How did the surface wind speeds respond to this pressure gradient change? So for question 5, you're going to the areas that you would consider the upper Midwest, which is going to be kind of our Dakotas kind of region. And you're going to take a look at what's going on and see what's the difference. So on the first day, let me flick back to the maps. On the first day of the storm development, the winds in the upper Midwest regions, which are kind of up here, are kind of coming from the north, right? I have this one right here that's coming from the east. So I've got some north winds. Most of them are from the north. So that's how it starts. And then over the next course of the storm, as it progresses, it continues to develop. And this is when the storm actually hits everybody, right? So we're going to look at the major storm in these same regions. And we can see that it becomes a spinning air mass. Some of it coming from the north, but a lot of it coming from the east, right? A lot of this wind is coming from the east, so that's my wind direction, how it shifted. It went from being kind of a northwesterly to an easterly wind mostly. And then as far as the difference in pressure, that's a subtraction. So you're going to take the pressure in this area being see if we can find a pressure line to read, right? 1,012 was kind of our average pressure in this area, around 1,012, and it flipped to being down by 970, 980 in these similar regions. So the pressure change was about 25 to 32 millibars. And you just write a sentence that says something like the wind direction started in the north and it switched to come from the east as the storm hit, and the pressure dropped. And you could do it one of two ways. You could say the pressure dropped from 1,012 millibars to 970 millibars, or you can give me the average and you can say the pressure dropped by 25 millibars or 32 millibars, whatever state you pick to read your pressures off of. So I think you're getting a feel for it. Be very literal with these questions. Don't make stuff up. Look at the map. Tell me exactly where you're getting the information from. Just tell me the exact number, the exact pressure. Be literal. It's science. You're supposed to be literal.